Hi guys, welcome back to the vlogs.
Okay, 7.3 Pythagorean theorem, okay? Pythagorean theorem, you know this. You know a squared plus b squared equals c squared. What is your c squared always? The hypotenuse, okay? So the Pythagorean theorem, if a triangle is a right triangle, then the sum of the squares of its legs equals the square of its hypotenuse. We are familiar with that, okay? That's nothing new to us. We can handle that. We're going to use that information to solve some things. Okay, Pythagorean theorem. It says a leg of a right triangle is 12 and the hypotenuse is 13. How long is the other leg? What do I need to do?
Put it up in the whole height.
Okay, how do you set it up?
A squared plus b squared is c squared.
Okay, so we know a squared plus b squared equals c squared.
Isn't the hypotenuse always c squared?
It is, so I can plug 13 in here and say 13 squared equals 12 squared plus b squared. What is 12 squared? 144. What's 13 squared? 169. I subtract 144 now, yeah? And you get b squared equals what? What's 169 minus 144? 25. Then you take the square root of that, and you get what? B equals 5. So, our other leg is 5 units long, okay? That's the first thing of this lesson. You should be able to handle that, I'm pretty positive. Okay, pretty confident in that. Okay, so this is how we prove the Pythagorean theorem. Okay, the reason we can use the Pythagorean theorem is because if I have a square, okay, I can break it down into triangles and into other squares. So what they did is they took this square and they divided it in so that there is a square here in the center, okay? And off of that, you now have an A, a B, and a C. That's where we get our hypotenuse and where we get our legs from, is from taking a square and dividing it into right triangles inside of a square. Okay, when you do that, you want to start with your equation, okay? So here's what we're going to talk about. To prove the Pythagorean theorem, we start with a square within a square, okay? So we have this beautiful square right here, oops, within our square, okay? Okay, so we're starting with that to prove why this works. So if we label the triangle so that the hypotenuse of each is C, a side of the larger square, their legs are A and B, we place 4 congruent right triangles inside a larger square, which creates a smaller square. We then compute the area of the larger square as the sum of the areas of the triangles of the smaller square. So what it's saying is this. How do you find the area of a square? Side times side. What is our side labeled as? C. So we get C squared. This is where the formula comes from. Okay? How do we find the area of this square right here? It does kind of look like it's half of B, but I also have A here, don't I? So I have A here, and I have this whole part of B. Okay? So, I can set up a formula that tells me that if I take, technically this is half of A, this segment right here, right? And this segment right here is half of B, yes? Okay. And on a square, how many sides do I have? 4, okay. So if I set C squared equal to 4 times, okay, 4 times 1/2 of AB, okay, because this is half of A, this is half of B, okay. If I take that and set that up and rework this problem, okay, and I add to it A minus B, okay, I add to it A minus B squared because here's what I'm doing, okay? I have 4 sides that are either a half A or a half B. So I'm taking those 4 sides, multiplying by half A, half B. I'm adding it to A minus B squared because I have to take the whole length of A and the whole length of B and subtract them from each other to get what that difference is, to see what gap I'm missing, okay? Squared. So when I do that, I can then create this problem that's going to come out to allow us to do some work. So from here, I would simplify this. You're gonna get C squared equals, when I multiply this into that, what do you get? When I multiply 4 into a half AB, what do you get? 2AB, yeah, 2AB. So I get 2AB. What happens when I have A minus B squared? What does that mean I have to do? No. How many sets of parentheses do I have? No. If I have a squared, I have 2, so they're going to FOIL. So I'm going to add it to FOILing this. Okay, what's A times A? A squared. And then I have A times negative B. Negative AB. Negative B times A. Negative AB, I can write it the same way. And negative B times negative B gives me B squared. And now I'm adding it to all of this. Watch. So you have C squared equals 2AB, right? What happens here? I have negative AB and negative AB. So how many negatives do I have? So 2AB minus AB cancels. And I get what? And that's how you get Pythagorean theorem. And that's why it works. No one's probably shown you why we actually have Pythagorean theorem before. So that's great, okay? Just a little proof as to why that works. So we can solve using Pythagorean theorem. Okay.
Yeah.
Okay. So finding the area of an isosceles triangle. What do we know about isosceles triangles?
They have 2 equal sides.
They have 2 equal sides. So if I split them down the middle with a perpendicular bisector, I can create 2 equal right triangles. Okay? So if I want to find the area of this isosceles triangle, how would I set that up? What'd you say? Okay, what'd you say? I didn't hear it. That's fine.
12 squared plus 10 squared.
Nope. That 10 is my hypotenuse, so it's my C squared, okay? So I have 10 squared, okay, equals 12 squared plus B squared. Not 12 squared though. I have 10 squared equals what? 6, because I have to take half of this, okay? Equals 6 squared plus B squared, yes?
Is the 6 always the A? Or like would that always
No,
be A? It
no,
doesn't
no,
matter?
no, it doesn't, yeah.
Okay.
So I get 100 equals 36 plus B squared, so that means B squared equals 64, yeah? So B is gonna equal what? Okay, so now I know the height is 8, which is good because when I find the area of a triangle, what's the formula? A half base times height, right? So I needed that height, so I have a half base times height. Okay, now can I find the area of this triangle? Okay, what do I do? 1/2 times what?
8 times 6.
No.
6 times, wait. Would it be 6?
No.
It would be 12.
It would be 12 because I'm finding the area of that whole triangle now.
Oh, okay.
You gotta think a little bit, okay? So don't get confused by that. So now I'm doing a half base times height, so 12 times 8, right? What is 12 times 8? Divided by 2? It should be 12 times 8 is 96, right? And then divided by 2. So 48, is that right? Yeah. So I get 48 units squared, because I don't have a unit rate right now, okay? So you're gonna use the Pythagorean theorem to get you to a place to be able to use, find an area of something, okay? Okay. There is something called a Pythagorean triple, okay? There's special types of right triangles. So a 3, 4, 5 is a Pythagorean triple. 3 squared plus 4 squared equals 5 squared, okay? It's a special pattern, it's an order, okay? And there's a bunch of them. So we have something called Pythagorean triples, and we're gonna talk about how you can figure those out and how you can calculate those, okay? So on a Pythagorean triple, you need to know this. There are 3 formulas that happen with Pythagorean triples. If your m, okay, we're gonna talk about what this means in a minute. If m is less than n, you can plug things in to solve for a, b, or c. So if I'm missing 2 sides, I can plug stuff in to find a, b, or c. So a would equal n squared minus m squared. B equals 2 times m times n. And c equals n squared plus m squared, okay? So write those down, and then we're gonna take a look at those in a second with something else. Because you'll need those formulas later on.
So,
So
never mind.
this is for a Pythagorean triple. Okay? Pythagorean triple is a set of 3 integers that satisfy the Pythagorean relationship. 3, 4, 5 makes a Pythagorean triple because 3 squared, 4 squared equals 5 squared. Okay? 6, 8, 10 is a Pythagorean triple because 6 squared plus 8 squared equals 10 squared. Okay? 9, 12, 15. Okay? See how those are all multiples of what? What's 9, 12, and 15 all multiples of? 3. Okay? 6, 8, and 10 are all multiples of what? 2. Okay? 5, 12, and 13 is a special type of Pythagorean triple. 10, 24, and 26 is a form of a Pythagorean triple. There are a bunch. A formula known as, this is called Euclid's formula, allows you to generate Pythagorean triples. This is so when you want to find Pythagorean triples, I use this, okay? So make sure you have that written down someplace that you know that that's what it's for. It's only when I'm trying to find a triple, okay?
This whole A equals.
Yes, is when I'm trying to find a triple, okay? It's to generate Pythagorean triples from a pair of positive integers, m and n. It is closely related to the proof of the Pythagorean theorem, okay? So the formulas let you calculate 2 legs and the hypotenuse, okay? Keep in mind that m needs to be less than n. M has to be less than n, okay? And then you can use the formula to calculate the hypotenuse. So like on your homework, they're gonna give you things that say m equals or n equals, and you want to plug it into these things, okay, to see if it's a Pythagorean triple. So what's gonna happen is you'll plug it in to figure out what A is, you'll plug it in to figure out what B is, you'll plug it in to figure out what C is, and then you can see if that's a triple from there. Does A squared plus B squared equal C squared, okay? So let's say I give you, let me see if my next slide has numbers on it or not, I don't remember. No, okay. So let's say I give you this. Let's say it says m equals 5 and n equals 7, okay? I need to figure out first what A is, what B is, what C is, before I can decide if it's a Pythagorean triple, okay? So if I plug this in, first of all, m is less than n, so I can work from here. If m is not less than n, you just stop there and you say it's not possible, because m is greater than n, okay? So I start here, and I say A equals 5 squared minus, no, by the way, I wrote that backwards. It should be 7 squared minus 5 squared. So I have 49 minus 25, which is what? 20, right? Not 20, 24, which is 24. Okay, to solve for B, I take 2 times 5 times 7. 5 times 7 is 35. What's 35 times 2? So B equals 70. And then to find C, I say n squared plus m squared. N squared is 49, right? Plus 25. What's 49 plus 25? 74. Okay. So I have A, B, and C now. Okay. So to express it as a Pythagorean triple, okay, I'm then going to list it in the order that it would be. A is always your smallest, C is always your largest. Okay, think of the alphabet. So 24, 70, 74. You see how that works? Okay. So Kayla, when you were asking me about Pythagorean theorem and using it, your A is always your smaller number.
Okay.
Okay. Okay, so they might ask you on your homework to find Pythagorean triples using these formulas. That's what you need to do. Okay? And then you'll list it in order of least to greatest. Once again, the formulas for Pythagorean triples, and they gave us another example of m equaling 8, n equaling 11. So what do I need to do to figure out what A is?
A equals n, or 11 squared minus 8 squared.
Okay, and that makes sense because A should be your smallest, so you take the largest minus the smallest. You get what I'm saying?
Yeah.
Okay. You want it to come out. So 11 squared is 121, and 8 squared is 64, yes? So 121 minus 64 is 57. Then I find B by doing 2 times 11 times 8, right? So what's 88 times 2? 8 times 2 is 176. And then I do C equals n squared, which is 11 squared plus 8 squared. So I have 121 plus 64. So 175. Is that right? 121 plus 64, 185. There we go. That wouldn't be right because your C has to be your largest. So my Pythagorean triple is 57, 176, and 185. And so that's why we have a formula for it, because there's infinite solutions for Pythagorean triples. Cool?
Yeah.
Okay, we're gonna do some homework. Go for it.
Come on, Faith. Like, subscribe, comment, tweet me at David Dobrik. Anything else to add, Faith?
Don't subscribe.